All right, so for this practice problem, we have a coral reef that is 2 miles due south of its closest point along a straight shoreline. A visitor is staying in a cabin that's about 4 miles west of that point. The visitor is planning to go from the cabin to the coral reef. Suppose the visitor runs at a rate of 6 miles per hour and swims at a rate of 3 miles per hour. How far should the visitor run to minimize the amount of time it takes to reach the coral reef? Round to 2 decimal places. So we have a nice diagram here. So we have some options for this visitor, right? They could run all 4 miles, and then they could swim 2 miles. That's probably not the most efficient. Or they could run for a little bit and then swim the rest of the way. But we want to know how far should they be running and then how far should they be swimming. But notice that the furthest they can run is 4 miles. So that would be all the way here would be 4 miles and then 2 miles swimming. So that's kind of our domain, and we'll need that at the end. This is a long problem, so bear with me here. So we need to label some things. So let's let the distance that we run, or the visitor run, let's call that X. And then the distance that the visitor swims, let's call that Y. So the first thing you should notice is that we want to express Y in terms of X. And we have this nice right triangle here. So let's look at this distance here. So the full distance from the cabin to the spot on the shoreline that's straight north of the coral reef is 4 miles, and this piece that we're running is X, then this is going to be 4 minus X. And then we have this nice right triangle. So let me switch here. So we have the distance that we are running is going to be X, and the distance swimming is going to be Y. And we know that if we take 4 minus X squared plus 2 squared, that we will get Y squared using the Pythagorean theorem. So we're trying to minimize the time. So let's talk about how much time it would take for each one. So we're going to use that distance equals rate times time, which means that if we divide both sides by r, distance over rate will equal our time. So our total time for this trip is going to be the time it takes to run plus the time it takes to swim. Well, the time that it takes to run is going to be the distance that we run divided by the rate at which we run. I don't know why I keep saying we, but this visitor. So the distance that this visitor is running is X, and the rate, let's see, the rate at which they run is 6 miles per hour. The distance that the visitor swims is this distance here. Is Y. And the rate of swimming is 3. So this is the total time. And I want to express time in terms of just one variable. So that's where I'm going to use this relationship over here. So we've got X over 6, and then Y, if I take the square root of both sides, is going to be the square root of 4 minus X squared plus 4 all over 3. So we want to minimize this time, so we need to find a critical value, which means we need to take the derivative of this and set it equal to 0 and solve for x. That's going to be the fun part. So the first thing I'm going to do is just kind of express this in a way that I can use the power rule. So I'm going to write this as 1/6 x plus 1/3 times this 4 minus x squared plus 4 to the 1/2 power. So I'm going to bring this over to the next page here. Let me copy this. And let's bring it over here. Come on. I don't know why that's... Okay, so there's our function. We need to find the derivative of this. So we're going to find the derivative with respect to x. Well, this first one is nice. It's just 1/6. It's this next piece where we're going to use chain rule, and we're going to have to do it. We've got kind of 2 insides here. So the first is the very, very outside of 1/2. So we're going to take that 1/3, we're going to drop the 1/2 down in front, and we're going to decrease it by 1. Then we have to take the derivative of what's inside the first set of parentheses. So we have this 4 minus x squared. So we're going to drop that 2 down in front and decrease it by 1. And then the derivative of 4 is just 0. And then we need to take the derivative of the inside of our innermost parentheses, or the derivative of 4 minus x, which would be -1. So there's our derivative. We need to clean this up a little bit. So first note that this 1/2 and this 2 are going to cancel. I'm going to bring this -1 out here to call it a minus sign. So we will have that the derivative is going to be 1/6 minus 4 minus x over the square root of 4 minus x squared plus 4. And we want to solve this, or we're going to set this equal to 0 and solve for x. So, oh, I'm missing my 3. There's a 1/3 there. There we go. All right, so let's set this equal to 0. And we can bring this complicated piece over to the other side. So I'm going to bring this 4 minus x, since it was negative, I'm going to bring it over here and make it positive. And so this is going to equal 1/6. And then let's cross multiply. So we'll have 6 times 4 minus x equal to 1 times 3 times the square root of 4 minus x squared plus 4. And then we can divide both sides by 3, at least simplify that a little bit until we have this. So we're still trying to solve for x here. So right here, we're going to square both sides. So I'm going to square this side and square this side. Let's bring it up here. So when we square the left side, we have to square the 2 to get a 4. And then we're going to square 4 minus x squared. And I'm not going to FOIL that out because I've got another 4 minus x squared on the other side. So on the other side, when I square that, I'm going to have 4 minus x squared plus 4. And now, these little pieces I want to get rid of. So now let's subtract this 4 minus x squared from both sides. So I'm going to subtract this, and I'll have 3 times 4 minus x squared equal to 4. And I'm trying to isolate this 4 minus x squared to give me 4/3. And now I can take the square root of both sides, and I will get 4 minus x equal to plus or minus the square root of 4/3. And then if I solve for x, I will get 4 plus or minus, I'm going to write this as 2 over the square root of 3 is going to equal x. So I have an x equal to 4 plus 2 over the square root of 3, and an x equal to 4 minus 2 over the square root of 3. So let's figure out what those values are. When you do the addition piece, you'll get about 5.15, and the